The Great Red Spot is not a storm, not in any sense you would recognize. Storms end. This one refuses. Every hurricane on Earth dies. This one has not. Something else is happening on Jupiter. For at least 195 years, astronomers have aimed telescopes at the same patch of the same planet and found the same red oval waiting for them. Different centuries, different countries, different instruments, the same oval, turning in the same direction, at the same latitude, at almost the same speed. The longest-lived tropical cyclone ever recorded on Earth lasted 31 days. The Great Red Spot has been under continuous observation since before the invention of the telephone. And here is the part that does not fit. After outlasting 2 centuries of human record-keeping, it has started to vanish. It is measurably smaller than it was in the first photographs ever taken of it. In recent decades, the shrinking has accelerated. Something that should not exist at all is now ending. And the people who study it for a living cannot agree on what that means. There are 3 competing explanations. One says it is starving. One says it is not shrinking at all and we are misreading our own images. One says we are watching the end of something, in real time, with better instruments than anyone has ever had. They cannot all be right. In 2021, a team led by Marzia Parisi, a scientist at NASA's Jet Propulsion Laboratory, published a result in the journal Science that changed the question entirely. They had used the Juno spacecraft to weigh the Great Red Spot, not photograph it, weigh it. As Juno passed over the vortex at roughly 209,000 kilometers per hour, the mass of the spot pulled on the spacecraft. The pull was almost nothing, a shift in velocity of about 0.01 millimeters per second, measured from more than 650 million kilometers away through NASA's Deep Space Network. From that shift, Parisi and her colleagues extracted a number nobody had ever obtained: the depth. The Great Red Spot reaches as far as 500 kilometers below the cloud tops. That is farther than the distance from sea level to the International Space Station. Whatever this thing is, it is not a pattern painted across the top of Jupiter's clouds. It has roots. To put that in context, the atmospheric jets that surround the spot were measured reaching down as far as 3,000 kilometers. The vortex itself is shallower than the winds that hold it. It sits inside Jupiter's weather like a plug in a drain, connected to machinery far below the part we can see. And the moment you know it has roots, the word storm stops working. In 1665, an Italian-born astronomer named Giovanni Domenico Cassini pointed a telescope at Jupiter and saw a dark oval in the southern hemisphere. He watched it, he drew it, he named it the permanent spot. He was working with a lens ground by hand. No photography, no electricity. Isaac Newton was 22 years old. Cassini and his contemporaries tracked that oval for 48 years. They watched it circle the planet, disappear around the limb, and come back. They wrote down where it was. Then, in 1713, they lost it, and nobody saw anything like it again for 118 years. The record simply stops. There is a gap in the middle of the story of the most famous object in planetary astronomy, and it is longer than most countries have existed. Astronomers did not stop looking at Jupiter during those 118 years. Telescopes improved, observatories were built, the planet was mapped, its moons timed, its bands catalogued. The oval is absent from the record anyway. In 1831, a German observer named Samuel Heinrich Schwab recorded a clear oval structure at the same latitude. Schwab was a pharmacist who observed the sky as a hobby and is better remembered today for discovering the sunspot cycle. The trail picks back up. From that point, the observations never stop. In 1879, a British astronomer named Andrew Ainslie Common photographed it from Ealing in London using a 91-centimeter reflector, and the spot came out dark and unmistakable on the plate. Since 1878, there has been a continuous record of at least one measurement per year. Amateur astronomers with crosshairs etched into their eyepieces, waiting for the spot to cross the center of the planet's disk, timing it against a clock, writing numbers in notebooks. No single one of those measurements matters. All of them together are the only reason anyone can say what the Great Red Spot is doing over a human lifetime. Those notebooks are why we know what is happening now. In 1879, the Great Red Spot measured roughly 39,000 kilometers across its long axis. 3 Earths, side by side, with room left over. Today it measures around 14,000 kilometers. It has lost more than half of itself inside a single human record. Put a number on that. Roughly 25,000 kilometers of width, gone. That is twice the diameter of Earth, subtracted from an object, while people were watching and writing it down. In the Voyager images of 1979, 3 Earths would fit across it. Today you could fit 1, and almost nothing else. The measurement of that decline is not the work of one telescope. It is the work of a small number of people who have spent their careers watching one oval. Agustin Sanchez La Vega, a planetary scientist at the University of the Basque Country in Bilbao, has spent years pulling numbers out of 17th century pencil drawings, reconstructing the size of an object from sketches made by men who had no idea what they were looking at. Amy Simon, at NASA's Goddard Space Flight Center, has led the Hubble programs that track Jupiter's atmosphere year after year, building the modern half of the record. Michael Wong, at the University of California, Berkeley, works the same data from the fluid dynamics side, asking what the winds are doing rather than what the clouds look like. Caleb Keaveney began working on the problem as an undergraduate at North Carolina State University and continued it as a doctoral student at Yale. His interest is partly in Jupiter and partly in what Jupiter can teach us about long-lived pressure systems on Earth, the ones that park over a continent and produce heat waves that will not break. None of them are chasing a single dramatic discovery. They are keeping a ledger, and the ledger has started to show something none of them expected. To understand why the Great Red Spot is dying, you have to understand why it should never have lived. Start with what it is not. A hurricane on Earth is a low-pressure system. Air spirals inward and upward toward a center where the pressure has collapsed. It is a wound in the atmosphere, and the atmosphere is trying to close it. The Great Red Spot is the opposite. It is a high-pressure system, an anticyclone. Air is pushed outward, not sucked inward. It is not a wound, it is a bulge. That distinction is the whole story. A hurricane needs warm ocean water to survive. Move it over land and the fuel stops and the friction begins, and within a day or two, it tears itself apart. This is why storms on Earth have a lifespan measured in days. Jupiter has no land, it has no ocean, it has no surface at all. There is nothing beneath the Great Red Spot for it to run aground on. If you dropped through the top of the clouds, you would not fall toward anything. The gas around you would get denser and hotter, and denser and hotter, and it would keep doing that for thousands of kilometers, until the pressure crushed hydrogen into a state that conducts electricity like a metal. There is no floor, there is only a gradient. Remove the coastline from a hurricane, and you remove the clock. But that alone does not explain it, because a storm with no friction still spreads out. It should smear across the planet and dissolve into the background. Something holds it in one piece. 2 jet streams do. Directly north of the Great Red Spot, a band of Jupiter's atmosphere moves west. Directly south, another band moves east. The spot sits in the gap between them, gripped from both sides by winds running in opposite directions. Picture a marble held between your palms while you slide one hand forward and the other back. The marble does not go anywhere. It spins. The Great Red Spot spins, counterclockwise. One full rotation takes about 6 days. 6 days for one turn. On Earth, the eye wall of a major hurricane completes a rotation in a few hours. The scale is what slows it down. A single lap around the Great Red Spot is a journey of tens of thousands of kilometers, and the material making that lap is moving fast enough to cross the United States in under 8 hours. Its own winds are not gentle. Near the outer edge, they run between 430 and 680 kilometers per hour. The strongest tornado ever measured on Earth would register as a breeze inside it. And the center is calm. Like a hurricane, the Great Red Spot has a quiet core surrounded by a wall of moving air. If you could stand in the middle of it, on nothing, because there is nothing to stand on, the violence would be happening entirely at the horizon, in every direction, forever. And underneath, the structure keeps going. Juno's microwave instrument found the vortex extending below the level where water and ammonia are expected to condense, below Jupiter's weather layer entirely. The jet streams that hold it in place reach down as far as 3,000 kilometers. This is the part that makes the word storm feel small. A storm is an event. It happens to a planet. This is closer to a fixture, a standing feature of Jupiter's circulation, 500 kilometers deep, locked between two rivers of wind, drawing its stability from the rotation of the planet itself. It does not sit on Jupiter. It is part of how Jupiter works. There is one thing about it we still cannot explain, and it is the part everyone knows: the color. Nobody has identified the compounds that make the Great Red Spot red. The leading idea involves photochemistry, sunlight breaking apart molecules high in the haze above the vortex and producing something like smog. The most recognizable feature in the solar system is named after a property we cannot account for, which brings us back to the problem. If it is that deep, that stable, that structural, why is it shrinking? A hurricane dies because it runs out of warm water or hits a coastline. Neither applies here. Whatever is removing the Great Red Spot is not the mechanism that removes storms from Earth, which means the answer has to come from somewhere we have never had to look before. 3 explanations are currently on the table. All 3 come from published research. All 3 are still standing. The first is starvation. In 2024, Caleb Keaveney, then at Yale, published a study in the journal Icarus with Gary Lachman of North Carolina State University and Timothy Dowling of the University of Louisville. They ran 3-dimensional simulations of the Great Red Spot and fed it a diet. Jupiter constantly produces smaller storms. They drift into the Great Red Spot and get absorbed. It has been watched happening. The assumption had always been that these collisions damage it. Keaveney's team found the reverse. Each smaller vortex that merges in adds spin. The more it eats, the stronger and larger it becomes. When they ran the simulation with fewer small storms available, the Great Red Spot shrank. The mechanism is a quantity called potential vorticity. Each incoming vortex carries spin, and when it merges, that spin is not cancelled. It is added to the pool. The Great Red Spot does not survive despite being hit. It survives because it is being hit. Under this hypothesis, the spot is not sick, it is hungry. Jupiter's southern hemisphere is producing fewer meals than it used to. Keaveney's team drew the comparison to heat domes on Earth, enormous high-pressure blocks that stall over a region for weeks and are sustained by smaller weather systems feeding into them. The largest structure in the solar system and a heat wave over a continent may be running on the same trick. The second explanation says the shrinking is partly an illusion. Philip Marcus, a fluid dynamicist at the University of California, Berkeley, has argued for years that we are not measuring what we think we are measuring. Nobody has ever seen the vortex. We see the clouds above it. Those clouds can flake, stretch, and tear off without the engine underneath changing at all. In the spring of 2019, amateur astronomers around the world watched large red streamers peel away from the eastern side of the spot. Images circulated. The word unraveling appeared. For a few weeks, it looked as though the object was coming apart in public. Marcus's group argued those streamers were the ordinary signature of smaller storms interacting with the vortex, clouds being shredded off the top while the engine underneath turned exactly as before. The spot stabilized, the flakes stopped, nothing had changed. And there is measurement supporting a version of this. Work led by Amy Simon found that as the Great Red Spot narrows, it appears to be growing taller. The volume may be conserved. The oval may be turning into a column. Under this hypothesis, the spot is not dying. It is changing shape, and we are reading the change wrong. The third explanation is the one nobody wants to say out loud, that this is simply what the end looks like, and we have arrived in time to watch it. Sanchez-La Vega's measurements put the average rate of decline at about 0.18 degrees of longitude per year, roughly 207 kilometers of length lost annually. In recent years, that rate has increased toward 0.3 degrees. Extend that line far enough, and the Great Red Spot becomes a circle, and then a point, and then a memory. The honest position is that all 3 hypotheses fit the available measurements. The spot is shrinking. It is also getting rounder, taller, and faster. It is also absorbing fewer storms. Every one of those statements is supported, and they do not resolve into a single story. 3 explanations: starvation, illusion, and death. The data does not yet separate them, and notice what every one of them assumes. All 3 treat the Great Red Spot as a single continuous object, with a single continuous history, something that began at some point in the past and is now doing whatever it is doing. That assumption is the oldest thing in this story. It is also the one that broke first. In June of 2024, Sanchez-Lavega and his colleagues published a paper in Geophysical Research Letters that reframed all of it. They went back to the drawings. Not to new data, not to a spacecraft, to 350 years of paper. Every surviving sketch of Cassini's permanent spot between 1665 and 1713. Every drawing from the 1830s and 1840s. Every photographic plate from 1879 onward. They measured each one, length, width, latitude, drift speed, and laid them on the same graph. The 2 objects do not match. Cassini's permanent spot was between 2 and 3 times shorter than the Great Red Spot photographed in 1879. Its motion across the planet does not line up. Run the numbers forward from 1713, and you do not arrive at what appeared in 1831. In the paper's own framing, it is highly unlikely that today's Great Red Spot is the permanent spot Cassini observed. Sit with what that means. The permanent spot was not permanent, it formed. It persisted for at least 48 years, and then, somewhere in that 118-year gap in the record, it died. Jupiter erased its most famous feature once already, and nobody was watching. There is no record of how it went, no sequence of drawings showing an oval getting smaller and rounder and fainter until the paper is blank. It happened during a period when astronomers had telescopes, had interest, and had Jupiter in the sky most nights of the year. The event that would answer every question we are asking right now took place in full view of a civilization that failed to write it down. Then it built a new one. Sanchez-Lavega's team also modeled how. They ran simulations of Jupiter's wind field and let it evolve. Their results suggest the current Great Red Spot grew out of an instability in the jet streams themselves. The winds went unstable, rolled up into a long cell, and then contracted and organized into the compact oval we recognize. Which means the thing did not arrive from somewhere. Jupiter made it, out of its own weather, in roughly the time it takes a country to industrialize. The object is not an ancient survivor from the age of Newton. It is roughly 195 years old. It is the second one, and it may not be the last. This is the answer to the question we started with, and it is worse than a storm. A storm is a thing that happens to a planet. What we are looking at is a thing the planet does. Jupiter's atmosphere is capable of assembling giant vortices out of its own turbulence, holding them for centuries, letting them collapse, and building replacements. The Great Red Spot is not an object with a lifespan. It is a phase in a process. And every measurement we have of it, every notebook entry since 1878, every Hubble image, every gravity reading from Juno, covers a single instance of that process, caught somewhere in the middle. We have never seen one of these begin. We have never seen one end. Every number in every notebook since 1878 describes the middle of a story whose beginning and ending both fall outside the record. We may be about to close that gap. There is a detail in the Hubble record that has not been explained. In 2024, Amy Simon and her team published a study in the Planetary Science Journal based on 90 days of continuous observation between December 2023 and March 2024. They tracked the Great Red Spot's size, shape, color, brightness, and spin through one full cycle. It was oscillating. Over 90 days, the spot squeezes and expands. When it drifts slowest, it is at its widest and most oval, and its core glows brightest in ultraviolet. When it moves fastest, it narrows and rounds out. Then the cycle repeats. In Simon's words, they did not expect to see the size oscillate. Nobody has a fluid dynamic explanation for the 90-day rhythm. Neptune's dark spots oscillate on a similar cycle, but they wander in latitude and tilt. The Great Red Spot stays exactly where it is, held by the jets and pulses in place. It was found because someone pointed a 34-year-old telescope at the same target on 8 separate dates and looked carefully. There is no instrument that detects an oscillation. There is only the decision to keep measuring after you already have the answer you came for. That is what the entire field runs on: continuity of attention. The gravity measurement that gave us the depth exists because Juno happened to fly directly over the vortex twice, and because someone thought to try it. Juno launched in 2011 and has been orbiting Jupiter since 2016. Its funded mission expired in September of 2025. Its future is unresolved. The next spacecraft built to study the Jupiter system in detail does not arrive until the 2030s. There will be no spacecraft measuring the Great Red Spot's mass in the near term. What remains is what has always remained: telescopes on Earth, pointed at a red oval, adding one more line to a ledger that goes back to 1878. The people who started that ledger died without knowing what they were recording. Schwab was looking for a planet inside Mercury's orbit and found a sunspot cycle instead. Common was testing a mirror. Cassini thought he was watching something permanent. The people keeping the ledger now will hand it to someone else, and that person will inherit a column of numbers going back to a time before anyone knew what Jupiter was made of. Somewhere on Jupiter tonight, a column of gas 500 kilometers deep is turning between two rivers of wind, as it has turned every night of every human life now being lived. It is smaller than it was when your grandparents were born. It will be smaller still when your grandchildren are. Nothing you do will affect it, and nothing anyone has ever done has affected it. And it has been indifferent to human beings for the entire time human beings have known about it. We do not know whether we are watching it die or watching it change. We know it has done this before, and that the last time, nobody noticed. That is the strange gift of living in this particular century. We have the instruments to see it, the records to compare it against, and no idea how the story ends. Every generation before us inherited the Great Red Spot as a fixed thing, a landmark, the one feature you could draw on a planet from memory, something you could point to and say, that has always been there. Cassini thought the same about his. He put the word permanent in the name. Ours may be the generation that finds out it was never a landmark. It was weather. It simply happened on a scale we had no name for. Thanks for watching, and I'll see you in the next one.